Hello and welcome to this video. In the previous video, we got an intuition about singly linked list. So in this video, we'll see how to add and remove elements from a singly linked list. So let's take an example. I have taken a linked list consisting of 4 elements 2, 3, 4 and 5. Now I want to add an element 6 to the linked list. Now add here actually means appending to the linked list. So after 5 I need a node with 6. So as we know, this node is actually the head of the linked list, and we have to traverse the linked list and we have to append this node here. So for that, it's really very simple. We just need to remove this, take this pointer and attach it here, and now this will actually be null. So that's how easy it is. So there's a special case. If the linked list is empty, then the head node is actually null. So we have to handle that case as well. So let's see how it's done. I have declared a class node. As we know, a node consists of a value and a pointer to the next node. I have declared the head of the linked list as null because linked list is empty initially, and length of linked list as 0. I have also declared a print list function. It will help me to print the linked list later. So for adding an element, I want to add this value to the linked list. So first I'll check if the head of the linked list is null or not. So if it is null, then I'll simply say this dot head equals to, and I'll create a new node and I'll set it to head. If head is not null, it will come in the else block. Now let's take our temporary pointer to head, and while temp.next is not null, I'll say temp equals to temp.next. So what this piece of code is doing is, while the temp.next is not null, so this is actually where the temp is pointing initially, then I am simply moving the temp pointer one by one, and when the temp.next is null, then it comes out of the while loop. After it comes out of the while loop, I'll simply create a new node with this element, and I'll say temp.next and I'll set it to new node. And lastly, I have to increase the length as well, and now it's fine. So this is how simple it is to add an element to a linked list. Now let's say I want to add an element to a particular location. Let's say I want to add a node, let's say 7, between 3 and 4. So it's actually the location 2. This is the index 0, this is index 1, and this is index 2. So in the index 2 we want to insert 7. So it's very simple. We just have to remove this pointer, and this pointer will point to this node, and the next to this pointer will point to this node. So now there's a special case here. If the index is 0, that means we want to insert an element at the head node. So if we want to insert an element to the head node, we have to simply assign head as the new node. So let's see how it's done. I'm writing a new function. Let's say public void add, and it will take a value and an index. So now if index is less than 0 or index is greater than or equals to the length of the linked list, then we will throw an illegal argument exception, because less than 0 index is not possible. Now if the index is 0, that means the special case, then what we will do is we will simply take a new node at first, and I'll say new node dot next as the head, and the head as the new node. Now obviously I have to increase the length since I have added an element. Now let's return. Now if the index is non-zero, I have to take, let's take a temporary variable I and a pointer to head node. Now while the index, while I is not equals to the index, so if we want to insert at position 2, that means index is 2, then we have to stop at this position. If we want to insert at position 2, we have to stop our pointer at temp pointer at this location. So while I++ is not equals to index minus 1, that means I++ not equals to 1. What we'll do is we'll simply increment the temp pointer. Now when it comes out of the while loop, we'll simply take a new node and we'll say new node dot next as the temp dot next, and the temp dot next as the new node. And obviously I have to increase the length as well. So that's how we add an element to a specified index. Now let's see how to remove an element from an index. Let's say I want to remove the element at index 1. So I want to remove the element 3. So for that, what I can do is I can simply change this pointer. I will just remove this pointer and I'll change it to here. So after 2, it will actually skip 3 and it will go to 7, 4, 5 and will be done with our job. So there's also a special case when you have to remove the head node. That means we have to remove from index 0. So let's see how to handle that case. I'll declare a function public void remove and it will take an argument as the index. Now if index is greater than or equals to length, or the index is actually less than 0, it is actually index out of bound because this index does not exist. Now the special case when index is 0, we can simply move the head node by one position and say head equals to head dot next. So what I'm doing here is, if this is the head node, I'm simply removing the head node and pointing it here. So this is actually removed now. So the head node becomes 3. So this is what is happening here. Now if the index is non-zero, then again I'll take I as a temporary variable and a temp pointer to head. Now again, while I++ is not equals to index minus 1, I need to increment the temp pointer, and when the temp pointer is just at the index minus 1 position, that means if I want to remove this element 3, the index should be at position 2. So when the when the temp pointer is actually pointing at the previous element, then we'll simply say temp dot next equals to temp dot next dot next. So what this piece of code is actually doing is, it's pointing here, temp is pointing here, and it's just saying temp dot next would be temp dot next dot next. That means it will point to 7 now, and obviously I have to decrease the length. So now let's check if everything works or not. So I'll say linked list and let's give it an integer value. Let's say list.add 5, list.add 10, list.add 15. Now let's print this value, print the whole linked list. Let's run. So 5, 10, 15. So it's correct, and let's add an element at the second position. So let me add a value 12 at position 2. So let's check now. Alright, so 5, 10, 12 and 15. Let's remove a value from this list. So remove the value at position 2. Now let's check. Yeah, so it works. Now let's remove the head of the linked list. That means remove the index 0. So the output should be 10 and 15. Yeah, fine. So this piece of code works fine, and that's all for this video. Thanks for watching.